Hello everyone. This video would focus on how to determine the nth root of a given number. Before we go over this example right here, please feel free to check out the description box below for the link of all the other series of topics related to radical expressions. Now let's have a review on the parts and definition of radical expressions. Please remember that these are the parts of every radical expression. The first part is the radical symbol. The reason why this is called radical expression is because it is an expression that contains the radical symbol. Our A here is called a coefficient. A coefficient is a number multiplied to the radical expression. And the letter N here is called the index. This tells you which root you're looking for. Please remember that if the value of the index is not written in there, it means that that invisible number is 2. We also have a letter C, and this letter C is named as the radicand. A radicand is the value that you are taking the root of. So this expression that we have here is read as A times the nth root of C. So this is read as square root of 36. So if we wanted to know what is the value of square root of 36, we can go ahead and equal this whole expression to x. So this is read as square root of 36 equals x. Now we are going to rewrite this into its equivalent exponential form. This expression or this equation that we have here means that x squared is equal to 36. What is x? So if you notice, our x here becomes the base of the exponential form, while our index of 2, which is invisible, becomes the exponent in the exponential form, and our radicand, which is 36, will become the answer to the exponential expression. What we're trying to do right now is we're supposed to determine the value of x such that when we multiply this x by itself twice, it will give us 36. Meaning if we have blank times blank equals 36, and it should be the same number. So then these two numbers would be 6 times 6. So 6 times 6 is 36. And so we can go ahead and rewrite this as 6 squared equals 36. And so this tells us that our x is 6. So then this square root of 36 then will equal to 6. So that's how we evaluate radical expression. So these are the parts and definition of radical expressions. Okay, going back to the problem right here, there are steps that we need to follow in order that we can evaluate this expression right here. The first step is to divide the radicand with a prime number starting with 2 and continue dividing with the rest of the other prime numbers such that you can get a remainder of 1. So I'm going to divide this 2,592 by 2. I'm going to show the work on the side right here. By the way, I will put the list of the first 10 prime numbers on the side for your reference. So we have here, that's gonna be 2,592, and then I'm going to divide that by 2. So this would come out 1,296. And then I will continue to divide that by 2. And so this would come out 648. So I write it down here, 648, and this is still divisible by 2, so I'm going to divide that by 2, so this will come out 324. I will continue to divide that by 2, so this will come out 162. So 324 divided by 2 is 162. We divide that by 2, 162 divided by 2 is 81. So 81 is not divisible by 2, but instead this is divisible by 3, which is the next prime number. So 81 divided by 3 is 27. I will divide that again by 3. And so we have 27 divided by 3 is 9. I will divide that again by 3. And so 9 divided by 3 is 3. I will divide that again by 3. 3 divided by 3 is 1. And so I'm able to get a remainder of 1. So these are the factors or the prime factors of 2,592. The second step is to write out the prime factors from step 1 and we simplify. So I'm going to go ahead and write that up here. So that is the fourth root of, so I'm going to put 4 right here. Now here's the thing. We are going to write down everything, all of them, in exponential form, or all the factors in exponential form. So in this case right here, we have 2, 1, 2, 3, 4, 5. There are 5 of them. So I'm going to go ahead and write 2 raised to the power 4. And then we have another 2 raised to the power 1. So let me explain this. So there are 5 2's here, and we are supposed to group these 2's by 4 since our index is 4. So then we go ahead and write 2 to the power 4, but there are 5 of them, so we still have 2 raised to the power 1. And then we count all the 3's. That would be 1, 2, 3, 4. There are 4 3's. So I put that up there. Now, what are we going to do next is we are going to break this down. So this would come out. That's going to be the fourth root of 2 to the fourth times the fourth root of 2 to the 1 times the fourth root of 3 to the 4. Now, please remember that if the index and the exponents are the same, we can cross them out. So these two we cannot, because that's a 4 and that's a 1. But this is a 4 and that's a 4. So that's the reason why I had to group them by 4. Now, if this is or if the index here is 5, so you group all the numbers by 5. So in this case right here, we are left with 2 times the cube root, or the fourth root of 2 times 3, because we already have canceled out the 4 and the 4. So 2 times 3 will come out 6, fourth root of 2. So this is the simplified version of this expression that we have up there. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to divide the radicand with a prime number starting with 2, and we continue dividing until the rest of the other prime numbers until we get a remainder of 1. So I'm going to divide this by 2. I will show the work on the side right here. So these are the prime factors for 486. So I'm going to go ahead and write that up here. So that would come out the fifth root of, so since this is fifth root, we're going to group them together into 5 groups, for each number into 5 groups. So we only have 2 here. It doesn't have any more partner, or it doesn't come out a team of 5. So I go ahead and write that up here as 2 raised to the power 1 times the 3 here. 1, 2, 3, 4, 5. They come in group of 5. So I can go ahead and say that that is 3 to the power 5. So that we can go ahead and break this radical. Each one gets the radical, and this is how it's going to look like. Now, we are going to cross out those index and those exponents that are the same. So this one is going to get crossed out, and so we are left with just 3. So this can be written as, so this is the simplified version of the fifth root of 486. Did you get the same answers as this? Good, perfect. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, the first step is to divide the radicand with a prime number starting with 2. And we continue dividing until the rest of the other prime numbers until we get a remainder of 1. So I'm going to show the work on breaking this 7,290 to its prime factors on the side here. Okay, so these are the prime factors of 7,290. The second step is to write out the prime factors from step 1 and we simplify. So this is the sixth root of, so we're going to count it. Since this is 6, we're going to group the numbers into groups of 6. So 2 is by itself, so I'm going to write that here. That's 2 raised to the power 1 times 5 is by itself, so that is 5 raised to the power 1. And then the 3 here would be, that's going to be 1, 2, 3, 4, 5, 6. So they come in group of 6. So I go ahead and write that up here. So this would be 3 raised to the power 6. And then we are going to break down this radical symbol. That means each of these numbers gets the radical symbol. So this is how it's going to look like. So we are going to cross out this 6 and 6 here. So this equation will come out. Okay, so what I did here was I put this into 3 here, which is the coefficient, because I crossed out the exponent and the index 6. So it came out 3. And since these two have the same indices here, and so I write that as the same index and I multiply the radicand. 2 times 5 is 10. And so this is the answer. Now, please remember, if these two radicands or if these two indices that we have here are not the same, we can't multiply them. But since they are the same, we multiply the radicand together and that comes out 10. Did you get the same answers as this? Good. Perfect. If you found this video helpful, hit like and subscribe for more math videos. See ya.